All right, so at the end of today's lesson, this is what our caterpillar will look like. We're doing something a little bit different here. Flash forward. You can see the body is fully modeled out. The limbs are properly following that body animation that we made a couple lessons back. And this is ready to go into the next lesson where we can animate the individual limbs and give them their own animations. But let's now snap back to reality where we left off at the last lesson. Okay, so we got a lot of work to do today. These toes that we made at the end of the last lesson to test our procedural distribution system, they make this animation look even crazier. So let's just flash back now to the beginning of the last lesson. Without those toes on, I think we can see a little bit better what's causing this crazy animation glitch. And I'll just explain that again because we're going to be fixing that today. This glitch is a result of basically using the parametric coordinates of the body. When we originally created that body animation, we took the V coordinate of the body, the way we modeled it, and we just drove this motion from back to front along the segments of the body. And so basically what you're seeing on those limbs is that they're copying that animation. You can even see them dividing themselves into little segments, and that motion's kind of cascading the same way that it should happen on the body. They should be following the body. They shouldn't be copying it. All right, so let's get started tackling this animation issue. And the procedural distribution system we made last time will play a key role in that. So for now, don't even think about how we're eventually going to animate the limbs themselves. Just think about if we were to fix this problem and just have the legs following the existing body animation, kind of like they're attached to the body. The way that you would fix that is that you could basically just figure out what is the UV coordinate at which point this limb branches off of the body. And you can just essentially take a paint bucket like we've got in MS Paint here, right? Where you can just fill some single value across all these different pixels, right? We could take that branch coordinate and fill each one of these vertices with that parametric branch coordinate across the entire limb. And then it should have the exact same animation on it then that the origin point gets where it's attached to the body. Now, you could get very sort of technical and say, well, actually, it's going to be attached at all these different various points, and we should make sure that we're filling those different values across all these. Yeah, technically, yes, that would be better. But for our situation, just the single branch point, I think, should be perfectly sufficient for getting the effect that we're looking for. So that's the simple way of just solving the broken animation, is to just take your paint bucket, right, and fill that branch coordinate into each one of these vertices of these limbs. So that explains how we would fix the problem. But now, what about what we're going to do in the next lesson, which is animate these limbs and give them their own animations? And then even beyond that, like what if we had these extra pieces coming off? They want their own animations, and they also need to animate as though they're attached to their immediate parent, right? Which then it needs to attach to its immediate parent. So it sounds like very complicated, right? How are we going to possibly do that? The way that I want to solve this is to use layers. And so basically we can say that our layer 0 or UV0 can correspond to our base mesh or body, okay? And then we can give our model a separate set of UV coordinates. We can create a UV1 layer where we can say that the local space parametric coordinates of the limbs, or any piece that's branching immediately off of this body, that model's local UV coordinate will be placed into this UV1 layer, right? And so then you could just keep going down. You have lots of these UV channels or layers available to you. I think it goes up to 7 at least. So you could keep going with this if you wanted to. And this will give us a way to ensure that our pieces are not only animating sort of in lockstep with the object that they're attached to, but they can also eventually do their own animation, and then the things that branch off of those will then attach to that as well. So then when we go to animate our mesh, we would then do that in layers as well. So anything that has this UV0 coordinate, it will have the body animation applied to that UV0 coordinate. And then we'll apply our limb animation to the UV1 coordinates and so on. All right, so final note before we get started on this, the way we're going to do this, let's put this all into a single mesh, because if you think about it, each of these limbs, right now we're just using the same mesh and we're kind of copying it and transforming it around. we're going to have to put unique data into each of these limbs because it's going to need to know where it is in this sort of layered or branching parametric space. And so because of that, they're going to need to have unique mesh data. We can just put this into a single mesh and it will kind of simplify this layering process as well. And so that might sound kind of complex and difficult. It's actually going to be really simple. The way I'm going to explain it is just think back to our lesson 1 where we talked about the quad, right? So we had something like that. And now just think about, rather than a single quad, what if we wanted to put multiple quads into the same mesh? Okay, so I'm drawing these points and now I'll start connecting the dots. Okay, so that was the triangulation pattern that we used in lesson 1. And then we also had these indices that we used to specify how to create that triangulation pattern. So it was something like that, like 0, 1, 2, 3. So then what we would do if we wanted to create copies of that essentially is that you could just keep counting up. So you'd say 4, 5, 6, 7, and then 8, 9, 10, 11. And so there's a couple of things to note here. First, if you were going to use the approach that we have been using, which is to use the same exact mesh and just render it in different locations, that's going to send a different transform matrix to the shader. But if you're going to want to create copies of it and put it into the same mesh, then you want to transform these vertex positions in the actual mesh, right? Because there's only one transform matrix that gets sent to the shader for this whole mesh, right? So we have to make sure that these positions are different in the mesh. So that's going to be one change. The other change is, as I've already drawn here, the index buffer, or the way that we're going to connect the dots. You're basically just going to use the exact same pattern, but you're going to offset it by the number of vertices that are already inside of that mesh, right? So if you see here, we had these indices assigned to these points. And then at this point, we already had 4 vertices in our mesh. So it's just those same exact indices plus 4. And then here we already had 8. So that's going to be pretty simple to just do this combined mesh idea. And it's going to also allow us to do this layering in a sort of more centralized location. So let's get to work on our, let's call it a multi-model mesh. Okay, so we've got the multi-model mesh. Let's open that up and let's grab some code from our parametric model. So we want to keep some of these attributes that will require our mesh filter and mesh renderer. And then let's also just get this information where we're setting up our mesh. You can see here also I added an ability to add a back face for those hind legs there. That's just something I did kind of off camera. If you were wondering how I made those hollow with back faces. Okay, so now we've got our build mesh function here. We're not going to use these. We need to make sure that we're including our system collections generic. Okay, and then here we're not really going to use this stuff, but we're just going to do this mesh setup stuff, okay? And so let's also require a multi-model. So this will be a component that's added to the same object that has a multi-model on it. That high-level object that's actually spitting out those instances. So we can get our multi-model and we'll just say get component on our sort of shared object that way. And we can just say, well, we want to make sure that we generate our multi-model before we start trying to put it into this mesh. Let's first generate that. And what we can also do is go into our multi-model. We can make this public even. We could get rid of this, right? It's just so that we can just then say at the bottom of this thing, we can say multi-model generated set active false. Okay, so that way we're only seeing the mesh version. And let's first do, for our texture coordinates, let's first do a version where we are not actually setting any texture coordinates. We're just setting, we just want to see if our combined mesh is working. Let's go over our multi-model instances that are generated by our multi-model. So we'll iterate over them here. Get components and children. And now what we want to do here is find a handle to the sort of template mesh that's been kind of copied and stamped along this scene. We want to, again, transform its positions and then also add some offsets to the triangles. So, and I'm just realizing this now, that template is actually a parametric model, but we're gonna actually wanna look at the mesh data that this model spits out. We don't wanna just look at this sort of parametric information. So we can say built mesh, and we can use our public getter, private setter thing that we already used there. And we can just say at the end of this, when we're building the mesh, we can just say our built mesh equals mesh like that. So that now we can actually look at this mesh data that's being output by our parametric model, which we'll need here. Okay, so first let's create a start index. So this would be like how many vertices are in this combined mesh when we're starting to add this instance. So we'll just say verts.count there. We'll use that to offset the triangle. So actually we can just do that now. We'll say for each int end in instance dot group dot template. So what we can do is let's first say mesh inst mesh equals built mesh. Okay, so now we just have a handle on that actual mesh, and we can say our triangles. And now we want to just add to our combined triangle list our local index plus our start index for our combined mesh. Okay, so that should get us our indices, and then we can go through our vertices in our instance, and this is going to be in the local space of the mesh. So now we can do what we did kind of in the last lesson when we were spawning the meshes. We can add to our verts, not inst mesh, but instance dot transform point of our local space vertex. Okay, let's transform that and put that into our shared vertex buffer here. Okay, so let's see if this works. So let's add our multi-model mesh to this now. And so we got our mesh filter, mesh renderer. Let's just put our caterpillar material on that. And then let's just move this up to the top so we can kind of get easier access to it. So let's cross our fingers here. Let's see if this works. Okay, it doesn't seem to have changed, but you can see this generated is off now. So if we turn off our mesh renderer, we're seeing this is all now in a single mesh, which is cool. And let's just take a look at that, make sure that that's giving us what we're thinking it does. And yes, it's all now in a single mesh. And so now let's get to work on actually adding those layers in to our UV coordinates. And that should, again, fix our animation glitch. And we can then spend the rest of the lesson just modeling out the caterpillar. So I call these layers for a reason. Think about what we did in the last lesson when we created our distribution system. And let's come over to our multi-model instance. And this already has a layer on it that is formatted the way that we want our UV layers to be set up. And so what we can do is, as we're building our multi-model mesh, we can see how many layers are there in these instances. So let's actually create a collection. Let's kind of store this in its own collection here. We can just say instance, an array, kind of like that, all instances like that, and then we can iterate over them there. But the reason I want to put it in its own collection there is let's get a max layer of all these instances. And actually, rather than just looping over it, I'll use one of my favorite namespaces here, which is system.link. And this would just allow us to do something simple like we can say all instances.max instance arrow, and this will kind of give us like this ability to get like an anonymous function that would transform our instance into its layer, right? So then we can say our max layer is something like that. Okay, so this is a bit of syntactic sugar. We don't really need to do it that way, but it's just one line now, rather than iterating over all these and saying layer max layer equals max of max layer and instance dot layer, right? Okay, but you can kind of just do that however you'd like. Hopefully that's a good enough explanation. Now with this max layer, and why did I want to do that? Because what I want to do now is I want to create a list of lists. And so we want to create as many texture coordinate layers as we have in our max layer. Because let's just come back to the whiteboard and visualize it. We're going to have our layer 0 and our layer 1. So that's going to be actually two different layers. So we want to say our max layer is 1. That means our n layers will be max layer plus 1. Okay, and then we can say our text chords list of lists will have as many lists inside of this as our n layers. So we'll say for int I equals 0, I less than n layers, right? Let's create our texture coordinates from that. We'll create an inner list for each layer inside this list of lists. Okay, so this is getting kind of complicated. Hopefully you're not losing the train of thought here. And really, so long as you understand the sort of conceptual layer of this, pun not intended, but well, let's go with it, then it should be fine, okay? And I should actually mention, as we're going along with this, because this is pretty advanced, if you have any questions, just don't hesitate, leave a comment, and I'll try to clarify as much as I can. I should have made a bigger deal out of that in earlier lessons as well. But I'm definitely watching the comments, and anyone who has questions, feel free to pipe up. Okay, so we've got this list of lists now. So before we fill it in, which we'll do in here, let's just go down here and we'll say for int layer equals 0, layer less than n layers, layer plus plus. Let's now say mesh.set UV. There we go. So then here it gives us the ability to pass in a channel, they call it. I'll call it a layer, but that's okay. So we'll say layer, and then we'll say our text chords at that layer will be the data that we're giving to our combined mesh. Okay, so that's kind of what we're using this list of lists for. Hopefully this is starting to make sense. Okay, so now let's just populate this list of lists here. Okay, so we want to do a similar thing where we want to iterate over the layers inside of this, and we can just grab the inner list as we're iterating here. Okay, so then we can say layer text chords equals, right, like that. Okay, so now what we want to do is actually fill those texture coordinates in layer by layer for this instance. And so this is where it's going to get a little confusing, I think. It's going to be dependent on which layer we're currently working on and which instance we're currently working on, right? So if we're currently filling a layer for an instance that lives on that layer, that's going to be kind of straightforward. That's just going to be the local parametric coordinates for that mesh, right? So if we're filling layer 1 for our limb, which lives on layer 1, then we'll use the limb's parametric coordinates. Now for layer 0 of the limb though, that's where we would break out that paint bucket and fill the branch coordinate into the entire layer, right? Now for the body though, obviously for layer 0, we'd put its own coordinates there. For layer 1, we'd still need to fill it with something, but we kind of have nothing we need to put there. We have to just make sure that we're sort of saturating all these channels with data, essentially, in order for this to actually work and not throw errors. So let's get our vertex count that we need to use here. We can say inst mesh.vertex count, and then we can iterate over all the vertices we need to add or texture coordinate data for these vertices. Vertex count here. Okay, so that will give us that. And so then here we can say if the layer is equal to our instances layer, right? So like let's say we're on layer 1 and we're working on that limb again, and that this is going to be not the instance mesh, but the instances layer, that metadata that we set up on the instance, right? Here we can just take our list here and add in our instance meshes UV sub vert ind, okay? So we can just basically pass through that actual texture coordinate in this case, okay? If our layer is greater than our instances layer, so this would be the case where we just kind of want to give it sort of dummy empty data, right? We can just add in vector 2.0, right? So this would be the case like if we're adding data for a limb, but we're working on the body. We just need to fill in this UV1 channel for the body with just sort of empty data. We would do that. Now this one is going to be, we can just say else. This would be if our layer is less than our current instance. So this would be like where we need to fill in this branching information. So if we're working on a limb, but we need to fill in layer 0 for our limb, okay, that's going to be that branch coordinate. So we can say layer text chords.add branch coordinate. Now, what is the branch coordinate that I'm adding there? And I'll just put it with a b lowercase there. So we can say up here, we can say our branch coordinate equals our instance dot branch coordinate. Okay, that's easy, but that will work fine for the case of the limb. What about if we need to fill in layer 0 for the toe though, right? So again, this is not something we're going to have in our actual mesh, but it's something that we need to make sure our system handles. That will give us the ability to fill in our channel 1 just fine, but what about our channel 0? So we need to actually do some traversal here. Okay, so it won't be too bad. We'll say multi-model instance here, parent equals instance dot parent instance. And then we can just say here, while parent is not equal to null and parent dot layer does not equal the layer we're trying to fill, let's traverse up this structure. And we can just say our branch coordinate in this case would be our parent's branch coordinate. And then we'll say the next parent to look at will be our parent's parent. Okay, and so that should traverse up this structure and fill in the appropriate branch coordinate into this variable here, which we then fill into our texture coordinates there. And then we come out of that loop and we'll see here, we're setting those texture coordinates on our mesh down here, layer by layer. So let's come out here and let's see if this works. So I'm going to rebuild our multi-model mesh. Don't see any errors. Now the moment of truth, let's turn the animation back on. And hey, it doesn't look good because of this just weird setup that we have just to see if this is working, but we're getting the correct animation behavior now. So I'm really happy with this. Hopefully you find this satisfying like I do, even though it doesn't look amazing right now. I think, part of that is these toes, they kind of look ridiculous. So, now that we just know that this nesting is working correctly, we could just delete this toe out and we can see this will look a little bit better. Without all that collision in there, right? But we're not really having the layout that we want here. And so let's work on that next. Let's actually start modeling this out now. And the first thing I'm noticing here is this distribution pattern, right? We could go in here and start fiddling around with this to try to find the exact coordinates we want to place these, like maybe like that. And then we can see what that will create, right? But we don't really want to do that. We don't want to spend all this time fiddling around to find the center of these segments where we want to place these limbs, because we should already have that information available to us, right? That's kind of part of the Caterpillar setup. And so I think what we can do now is let's create a scripting layer that will live kind of on top of the general purpose system we made last time. And we can put this just in the Caterpillar controller that we already have, where we're setting a shader global in there. And let's add some, specifically the multi-model group. Let's start scripting those from inside this. And actually now we're gonna have multiple things being driven by this number of segments. So let's actually split that off into its own variable, and we'll control it from the Caterpillar controller now. And so we can do that, and we won't actually gate that behind the segmentation source being not null now. Now what we'll do behind here is we'll actually set the frequency on that from what we have in this script. Now, right, this will be the sort of central knowledge of how many segments live on the Caterpillar, and we'll set things from there. And so now let's create some controls for the groups. So we could say, like, let's create like a Caterpillar group. So this will be a little bit more specific than our multi-model group that we currently have. We can just make this public, I guess. This will be serialized. And so we can bring in the system namespace. We can basically create some sort of Caterpillar specific controls for how we want to script this. So let's create first like a reference to the actual multi-model group. And then let's just say like our number of instances is something we want to set here. Rather than trying to say like the different iterations on U and V, we can kind of assume we're going to mirror one side of the body to the other. So we can just say the number of instances on one side. Then we'll say distribute from front, okay? And then we can say start offset. The assumption here is that we're going to be distributing these in the center of the segment. We're either going to be going front to back for this group or back to front, and we can start on either the first segment, or if we want to have some offset, we can then apply an offset and we'll just apply one instance per segment. So that's kind of the way I want to set up these groups for the caterpillar. And let's create like a array of these. And okay, now we'll just iterate over these caterpillar groups. Here, we'll say group.group, right? This is the multi-model group that we're sort of scripting with this. We'll say n iterations u will be 2 because we're going to mirror one side to the other. And actually, we need to also add like we'll say u offset. And we'll use this to kind of offset from the sides of the body rather than having to like manually calculate like, okay, do we want 0.55 and 0.95? This will kind of do that calculation for us. So we'll say min u will be 0.5 plus our u offset. And then here we'll say 1 minus our u offset will be our max u. Okay, now our groups and iterations v will be our other group. Maybe we can call this a cat group. Okay, so then this will be our cat groups n instances. Okay, now we just need to figure out what are these v coordinates from this. So let's create a function to get v coord from seg_ind. So we can pass in a segment index here. So let's go to the whiteboard and just see how to do that. I think it should be pretty simple. Let's say we have 4 segments. Just make it, that tends to be my example I always use, right? So obviously the distance between these lines here is going to be 1 divided by n segs, right? Because again, in v coordinate space, this is 0 and this is 1. So 1 divided by the number of segments will give us sort of the width. And then to get the center, this is just going to be 0 plus half of the width. So that's going to be the first center, and then we just add 1 sort of width from there with every additional segment that we want. Okay, so we can say here, this will be return 0.5 plus segment index times seg width. And what is our seg width? It will be 1 divided by number of segments. Okay, so that gives us our v coordinate from our segment index. Now here we can go back to front or front to back. Okay, so I'll say in offset direction equals our cat group from front, then we'll go in a positive direction. Otherwise, we'll go in a negative direction. So that's going to be our offset direction. Now we'll say our start segment. So if we're going front to back, our start segment will be 0. And if we're going back to front, it will be our maximum segment, which is n segments minus 1. Okay. Then we also want to make sure we're adding this caterpillar group has a start offset to it. So we'll say start segment plus equals our caterpillar group start offset, and then we just multiply our offset direction in. Right? If we're going back to front, we want to sort of subtract to this segment index. Otherwise, we want to add. Now for our end segment, we want to get our start segment and add in our n instances of our caterpillar group minus 1, because if you only have 1 instance, our end segment is going to be the exact same as our start segment, right? So we want to subtract 1 there and then multiply in again our offset direction. Okay, now we can just say start v equals, what did I call it? V coordinate from segment index. We'll say start segment. And we'll say end v equals n seg. And then we can just say caterpillar group. We can, on our group now, we can set our min v and max v. Or I don't think it really matters that our minimum and maximum are actually the minimum and maximum. So we could actually just do it like that. Even if we're going back to front, right, they'll actually be flipped, but there's nothing that's going to break as a result of that. So let's now set these up and see if this works. So now you can see, like, right, we're not seeing any segmentation anymore. So we need to come in here and make sure that we have 12 segments assigned. That's going to work correctly again. And actually, if we want to change the number of segments and we rebuild our multi-model mesh, we should see, right, we're seeing a different number of segments. So let's keep it as 12. And the legs didn't change because we didn't set up the caterpillar groups for those yet. So let's set up those kind of scripted groups now. And we'll say our hind legs here, let's say we want 5 and we want to not distribute from front. Start offset we'll keep as 0. U offset, I think we had that as 0.05. So let's see what that does. If we rebuild this, okay, we can see they're now perfectly positioned along those segment centers. Now that looks a little bit goofy, but I actually kind of think that will work pretty well. So maybe we just need to change the shapes of these a little bit. So let's keep that for now. And let's add another group. Let's add like our front leg group now. Okay. So we'll add our front leg template, and then we won't touch those other settings because we're going to script those from the Caterpillar controller. So let's do that. So we'll say front legs, and let's say we want 3, distribute those from the front, and we can rebuild. But I think we want, in this case, to have a start offset of at least 1. So we can try that. And so now we can see it's not on that front segment anymore. What if we want to add another start offset to that? Okay, so now we can see we're really starting to sort of get some better controls for setting these groups up. And we can also see, let's see what this looks like if we move this further sort of down on the body, and then even more what happens. Okay, so hopefully you're seeing kind of how this system is coming together here. And what I'm going to do now is I'm just going to put this into fast motion and really just start adding all these different groups that I'm thinking of adding. And we'll come back at the end to wrap this up. All right, so I'll just provide some commentary here while you're watching this. I started off by tweaking the shapes and the legs a little bit, and then working on the base mesh shape just to make it a little bit less simplistic and more kind of what I had in mind for the final result. Then I spent some time on the spots. I realized that was not exactly working the way that I had the sort of assumptions built into the caterpillar groups of that it would be the exact same thing copied across the body. There needed to be more than 2 iterations on U, basically. So I had the ability to turn off those U controls from within the caterpillar controller, and I just manually set those on the actual multi-model group. The other thing I changed was that I allowed it to kind of look at a negative U coordinate, which just helped me distribute those spots. And then I also added horns in the front and the back. Okay, so I think this is looking pretty good for our caterpillar. You know, it can be hard to just call it and say that's it, but you know, this is going to be animated too. So I think that's a good time to move on. And actually, let's just check our existing animation and make sure that's still working correctly. That's looking pretty cool, honestly. But we'll add animations for these different pieces that we added in today's lesson in the next lesson. So that's going to be really exciting. And quick before we wrap this lesson up, as I said that, I realized let's make one change to the layers we added. Let's add one more layer, and we'll put group and instance IDs into that. So here, let's change this to less than or equal to and layers. And this will just make the animation easier. So now we've actually got that extra layer. Now let's change this to less than or equal to. And again, we'll do it here. And so then here, we just need to fill in that new layer. So here we'll say if layer equals n layers. So that should never happen unless we just hit this new layer. Okay, so here we need like an instance ID. That should be pretty easy because we can just say like here, inst ID equals 0. So then just at the end of this loop, we'll just increment our instance ID. When we're done working on that instance, right, we'll increment that instance ID. So now we just need like a group ID. So let's just do it this way. This is kind of down and dirty, but it will do the job. So we'll do a group ID lookup, we can say. All right. And we'll just say group ID lookup if group ID lookup try get value instance group. So if we already added it, or let's say if we haven't added it already, then we'll say the group ID equals the current count of that lookup. So it will be 0 if there's nothing been added to it yet. And then let's assign that back there. Okay, that's not maybe the greatest way of doing this. You know, if we change the number of groups or if we move them around, the IDs might change on us. So it's not amazing, but it's okay. So then here we'll say layer text chords.add, and then we can just put in the group ID and our instance ID. So I think this will be useful when we go to actually animate this stuff, as well as I think in the beginning of the next lesson, what I want to do is to take this caterpillar that we just modeled and start adding some color to it in the shader as like a first sort of warm-up exercise for our animation. So I think that should be cool. Let's just make sure that this builds. Okay, it looks to be building. Now we'll kind of test those IDs out at the beginning of the next lesson, see if we did it correctly. But I think that's where we'll call this lesson, and I'll see you next time.